Hello students, so we'll see another numerical related to the key design. I'll read the numerical and simultaneously write the given data. The standard cross section of flat key, flat is important, flat is nothing but B is equal to D by 4 and H is equal to 2/3 of B, that is D by 6, which we have derived. Then having cross section 16 into 10, so B is width 16 mm and H height 10 mm, correct, with 50 mm diameter, shaft diameter, small d, 50 mm. The key transmitting 475 Newton meter torque they have given, so Newton meter, so we'll have to convert it into Newton mm, correct. So according to that we'll have to take that torque. So I'll write MT is equal to 475 into 10 raised to 3 Newton mm. Then from the shaft to hub, key is made up of steel having SYT yield strength or SYC crushing 230 Newton per mm square. Determine the length of key when factor of safety is 3. Length of key we need to calculate L, correct. So outcome is to calculate L. So as I told you, while designing the key, the basic information we must know BHL. B is given 16, H is given, now L is remain. So that we need to calculate for the key point of view. First step number 1, calculate the permissible stresses. Calculate the permissible stresses. I'll write permissible stresses. Now, while calculating permissible stresses, we know tau is equal to 0.5 SYT by factor of safety. So 0.5 SYT, how much? It is 230 divided by factor of safety, how much? 3. So therefore, we'll get the shear stress value is 38.33 Newton per mm square. Then crushing failure, sigma C is equal to SYC by Fs. So they have not mentioned any relation related to yield strength in compression. If they have mentioned it is 1.5 times or 150% more, I will have to write 1.5 times SYT. But they have not given as such, so we'll have to use same SYT 230 by 3. So here I'll get the value of crushing failure 76.67 Newton per mm square, correct. So this will be the step number 1. Now we'll move toward the step number 2. So for calculating the step number 2, as they have given the torque, so step number 2 was to calculate torque, but it is given. Now we'll have to focus on length. So for calculating the length, first of all we'll have to consider shear failure. Shear failure. Now while considering shear failure, we know tau is equal to 2mt divided by dBl. So here L is equal to, I can write L is equal to 2mt by dB tau. So I'll write 2 into 475 Newton meter they have given. So I will have to consider into Newton mm into 10 raised to 3. Correct. Then D, they have given diameter of shaft 50 into width 16 into shear stress. We have calculated permissible 38.33. So through which we'll get length on the basis of shear failure, we'll get that is 30.98 mm. Correct. So we can say 31 mm, nearly equal to. And from crushing failure, length will be, that is sigma C is equal to 4mt by dHL. In that case, I am interested for length, that is 4mt by dH sigma C. So 4mt is nothing but 475 Newton meter converted into mm we are getting answer. So D is 50, H is 10, and crushing failure is 76.67, through which I'll get the value of length 49.5 mm. So it will be around 50 mm. So likewise we have calculated the length of key. So this was the procedure. So you need to follow this procedure. I hope you understood this. Thank you.